Hello everyone and welcome back to this online NPTEL course on aquatic geochemistry. We had been discussing groundwater chemistry in our previous lecture, and in this lecture also we are going to continue some of this discussion. So, in our previous lecture we had started discussing this topic, that is the threats to groundwater, where we were just discussing this problem called groundwater salinization. Now, what is groundwater salinization? What do you mean by groundwater salinization? So, when we have groundwater, sometimes due to our activities, we are going to increase the salinity in the groundwater. That means, this water is no more acceptable for drinking purposes, and this is more common than we realize. Okay, so in several parts of the country, specifically where there is a lot of agricultural activities going on, groundwater salinization is an active process that is happening. So, when you think of groundwater salinization, you may have an idea that it is happening close to the coastal areas. No, it is not only happening close to the coastal areas, it can have it is happening also on the inside of the continent. Okay. So, let us see what are the processes that gives rise to groundwater salinization. So, of course, the first is the direct intrusion of seawater, which is localized near to the coastal areas only. Okay. So, what happens is that near to the coastal areas, the seawater is going to enter and it is going to mix with the water table here. Okay. So, you have this yellow zone, which is the unsaturated zone, and you have the saturated zone, which is the blue zone. Okay. And you see here in the ocean is green in color, and the ocean is slowly going to mix with the fresh water, which is more blue in color. So, depending on the mixing proportions, if you have wells here, if you have wells very close to the ocean, you are going to see that you are basically pumping the saline water. Okay. So, this is one particular reason, because it is close to the coastal areas, there will definitely be seawater intrusion. And as the aquifer levels are falling, as the recharge rates are going down, the coastal areas are more and more seeing seawater intrusion, because the natural fresh water supply is low. Okay. So, this is very specific to coastal areas. Okay. Now, what are the other processes that we are seeing? Okay. The other process is due to salinity dilution from fresh seawater. So, what happens? This river that is there, this can recharge the groundwater. It is recharging, it is just losing its water to the unsaturated zone from the banks of the river, from the bottom of the channel. It is just losing water to the unsaturated zone. Okay. So, this is going to dilute the salinity. Another process that is happening is from saline lakes. So, imagine you are also very close to a region where there is a saline lake. Now, how does saline lakes form? Either this lake has minerals, that is a catchment that has a lot of weathered material. So, they have all now got dissolved and the salts are remaining. This kind of salts are going to make the water very saline. Okay. And it is also possible that it is receiving runoff from agricultural lands. Now, let us understand why I am reflecting, why I am saying connecting between agriculture and salinity. When we do extensive agriculture, to maintain the nutrient, we are going to apply fertilizers, very common knowledge for everybody. Now, the common fertilizers that people apply, which is of inorganic nature, they are chemical fertilizers, and the most simple salts that is available and that is ready to be that's easily made are the chlorides. Okay, so you just are, if you want to add potassium to your soil, you may find, potash. So basically it's just some type of KCl, okay, KCl salt. So this KCl, if you are going to add to the soil, the potassium component will easily be uptaken by the plants. Okay, it's a nutrient, it's an extremely important nutrient for the plant. That potassium will go into the plant system, leaving behind a chloride. Okay, so all types of fertilizers, they are very rich in chloride concentration. Specifically the inorganic fertilizers, the fertilizers that are being made in factories and from other types of sources, they are very rich in chloride type of, they have a chloride base basically. So this kind of continuous usage of fertilizers builds up the salts in the soils. Okay, it just goes on building the salt concentration in the soils. So when there is runoff happening, when there is rainfall happening on these kinds of agricultural lands, the salts, they get dissolved, the chlorides are dissolving. So if you measure the salinity in this kind of water, and the water will be very saline, and it is not only moving laterally, it is also moving vertically. So the infiltration is also going to get inside the unsaturated zone. So extensive agricultural practices with a lot of fertilizer consumption aids to the salinization problem. And in fact, if you see historically, areas which have been going through a lot of extensive agricultural practices, they have very high saline groundwater. For instance, if you look into the Indo-Gangetic plains and regions where there is a lot of extensive agriculture, more and more groundwater now is coming up that is more saline. Particular places in Karnataka, particular places in Tamil Nadu where extensive agriculture is getting practiced, these areas which face comparatively less rainfall, okay, the soil becomes more and more rich in salts. So again I repeat, these are arid areas, that means less rainfall most of the time, extensive agricultural pressure, okay, maybe because of the soil type. So you have extensive agricultural practices, huge dependence on the groundwater therefore. So a lot of groundwater is extracted, being applied, and this area is what is going to make, so as the water is mixing with the salts, the water is also percolating, right. When you throw water on the agricultural land, when you are applying water on the agricultural land, it is just not the plants, it is the soil itself is again taking it back. So the moment the salts are also dissolving and the salts are also going in with the groundwater, with the fresh water, now you have saline water coming in. So this is the way that we are turning fresh water into saline water, because we are adding fertilizers, we are making these soil rich with salts, and we are going to add more water. So this is a very extensive problem, specifically in our country, because we practice all a huge application of fertilizers is practiced. What are the other kinds of so the leaching of salts beneath saline lakes and from saline lacustrine deposits. So either there are saline lakes, current lakes are saline, or there are lacustrine deposits. So the lake doesn't exist anymore now. The deposits, the lake deposits, lacustrine meaning coming from the lakes. So the lake deposits are there. The soils are more or less having a lot of salts. That kind of deposits also may release the salts into the unsaturated groundwater zone. Okay. Then natural weathering is also releasing salts. Okay, natural weathering of soil, of all the carbonates, of silicate minerals, they are also going to release a lot of types of soils, and which gets promoted due to dry weather. The salts are going to get accumulated. That is evapotranspiration happening, so they are going to get accumulated. So when the water infiltrates, so this is a rock. Okay, when the water infiltrates, again the water is infiltrating with saline water. So I just explained irrigational practices. Okay, fertilizer use, saline groundwater use, waterlogging. Then dissolution of minerals from rocks and mixing with the infiltration recharge water. Okay, so if this rain is happening here, there is a lot of recharge areas here. So the recharge areas are generally the uplands. Okay, because they have the gradient, they will be forcing the water to enter. So because of this gradient, because of this hydrodynamic gradient itself, these areas are more suitable as recharge zones. Okay. So the dissolution of minerals and rocks from these areas, they are going to infiltrate and they are going to go with the recharging water. Mineral dissolution from bedrocks and interaction with the groundwater. The bedrock itself has a lot of minerals that is continuously in reaction. Okay. So that is also contributing to the composition of the groundwater itself. Mixing of deep cornet water, which is of high salinity, with the groundwater. Now cornet water, this is trapped pore water. Okay, these are just like little pockets of water which got trapped in the formation. What happens is this water is remaining trapped for a very long time. So the TDS is very high, the salinity is very high. Because of the long residence time, it has accumulated all the salts. When this kind of cornet water mixes with the groundwater, when it mixes, again the salinity of the water can go high. Okay. So these are different kinds of changes. Then precipitation recharge causing salinity dilution, increased groundwater salinity from dissolution of minerals and mixing of deep saline cornet water. So the same thing. So this is mixing along the recharge pathways, and you are going to get more and more saline water because of this influence of cornet water. But among all these processes, the two processes that are extremely important for us to understand is that if we are decreasing the recharge rate in the coastal areas, if we are making more concretization, more urbanization, often we see near the coastal areas, then the groundwater levels will fall, the natural water level will fall in those areas, and more seawater intrusion is going to happen. Okay. So this is direct human activity impact on groundwater composition. Second of all is due to agricultural practices. When we apply a lot of fertilizers, we are adding more and more salts to the system, artificial salts to the system. These salts, they are not going to get removed, they are going to infiltrate the soil. The soil loses its texture. So often you see that they are going to say that please use more organic fertilizers, please use more organic rich manures and all that, because the soil will lose its property. The soil is going to gradually become more and more saline, and in saline soil nothing grows. Okay. So when extensive agriculture is practiced, the soil loses its fertility. That is because it is becoming more and more saline. Saline soils are of no use. Okay. So saline soils will give rise to saline water. So that is the case. So, wherever you know the soil has become saline, you know that the groundwater there is also becoming saline, and the more repeat cycles of you are having. So, the more fresh water you are drawing, you are throwing it on the fields. The fields are very saline, again the water percolates from those fields into the fresh the groundwater, and again that is pulled up. So, there are repeat cycles, continuously repeating cycles, and with each cycle the infiltrating water is getting more and more saline because of our continuous usage of fertilizers. So, this becomes therefore a huge problem for remediation becomes difficult, the entire soil is of poor quality, the water becomes of poor quality. Okay, so, this is a very common problem with groundwater, that is groundwater salinization. Let us look into some other problems like agricultural pollution. Just like I said, the application of fertilizers has increased the concentration of particular elements in the soil. So, these fertilizers, for instance nitrates, phosphates and all that, they are going to come, and what we do is we are applying more fertilizers than it is required. So, there is always an excess nitrate and excess phosphate that is going out as runoff. So, the runoff from that region, from that agricultural region, has high nitrate, has high phosphate and all other types of minerals, all other type of metals that is also coming from the fertilizer applications. For example, when we are applying phosphate fertilizers, cadmium is a very big problem. Cadmium is found in phosphatic rocks. Okay. It is a trace metal, it is there in the impurity. So, it exists as an impurity in phosphate rocks. So, when we are applying phosphate rocks and the fertilizers are added, these fertilizers are made from phosphatic rocks. Okay. So, when phosphate rocks are crushed and applied as fertilizers, then naturally this cadmium is going from the rocks into the soil. Okay. And by soil I mean it is not going to remain in the soil will also percolate, it will also leach it to the groundwater. So, there is contamination from fertilizer application, there is many metals that gets contaminated due to the application of fertilizers. Urban and industrial contamination. What is urban and industrial contamination? In urban spaces, other than concretization, other than recharge decrease, other than high demand, there is another problem, and that is waste dump. A huge amount of waste comes in from a small geographic area, and this is dumped. So, you will have an entire part of the city which is going to just go on making a mountain of the waste. And when rainfall is happening, when there is percolation happening, always from these waste dump areas, the leachates will come out, right. So, those leachates, that means whatever is getting leached, those leachates are going into the groundwater. So, they can be very high in certain contaminants, they can be very high in certain metal contaminants specifically, different kinds of contaminants can be coming in depending on what kind of area and what kind of resource waste is, how it is getting modified. Of course, there is no doubt industrial contamination is there. Many times it has been observed that the industries, they to prevent expenses, they are going to dump it into the soil. So, they are just going to dump their wastes into the soil. So, they are just going to dig some pits, digging the pits, they are going to dump their waste. What happens is they are relieved, but the soil, when it is leaching, when there is water, there is reactions going on, those leachates are again going into the groundwater. Okay. So, many times we have seen that from industrial areas there is a lot of contamination, the groundwater gets, in fact it is called contamination plumes. Okay. So, you can go and you can see that how that entire area gets affected because of that plume region near to the industry or near to waste dump area. Geogenic contamination. What do you mean by geogenic contamination? Now, naturally the rocks and the formations, they have certain compositions and in a concentration that may not be very suitable for our health. So, for instance, a very common geogenic contamination, the most widespread, is that of arsenic. So, arsenic you may have already heard is a very toxic element, and it is known for spreading a wide variety of diseases. It can start from simple skin inflammation diseases to very severe kind of illnesses. And this arsenic depends on the actual concentration in its bedrock. So, this is not any anthropogenic contribution. What rather we can say is this is just a kind of mobilization. Now, arsenic is there in different kinds of different forms. So, there is arsenite and there is arsenate. The more reduction, so the reduced form, that the arsenic 3 is the more toxic one, and when we are digging up a lot of wells, we happen to mix the arsenic. So, there will be certain zones which will have arsenic bearing pyrites and arsenopyrites, and these are the common minerals. These are the mineral types that is going to release a lot of arsenic into the system because of the sulfidic reactions, and it is coming from a geogenic source, but it is sometimes modified and mobilized due to lack of proper human management. So, there is sometimes a knowledge gap. So when it all started, people did not know that okay, where is the disease coming from, is it coming from food or what it is. So, only later was it discovered that this illness is related to water and specifically of this element called arsenic, and then they started monitoring the wells and they found all the wells that are so polluted. I am talking about this region in West Bengal and Bangladesh region and some parts of Bihar and Jharkhand area, and this entire zone is called the red corridor because of its immense arsenic contamination. So, this again, as I said, is a natural contamination. The source rocks may be coming from the Himalayan region. So, it is the sediments which came down weathered from the Himalayan Himalayan region, the floodplains, the Bihar, Jharkhand, Bengal, the entire Bengal delta, they are having those sediments, and these minerals, they are just getting modified and released due to our aquifer, poor aquifer understanding and poor management practices. A lot of research is going on and has been going on over the last past few decades. There is a lot of review papers, very good review papers available. If any of you wants to understand this kind of problems more deeply, I urge you to look more specific problems and go deeper into these problems. It is not only arsenic, there can be other elements, there can be uranium, there can be cadmium, the more the more toxic ones, these are the more toxic metals. So, wastewater infiltration and poor sanitation, sometimes we see that wastewater, the pipes are getting directly into the drinking water supply. So, such things are always happening, the wastewater is leaking, it is leaking into the aquifer. Okay. So, there are leakages, there is lack of infrastructure maintenance and all that. So, that kind of poor sanitation, poor maintenance, is also affecting the natural groundwater. Seawater intrusion, we have already talked about. Mining and resource extraction, this kind of influence we see mostly in places where there is ore mining. So, where there is a lot of mining going on, gold mining, copper mining, this, that, iron mining, everything, targeted areas in Jharkhand and in Karnataka, where there is a lot of mining activities going on. There you will see that the mine waste water, very acidic in nature, having extremely high concentration of particular metals, specifically arsenic, copper, iron very high, nickel, then chromium, cadmium, lead, mercury. These kinds of very high minerals will be, metal concentrations will be there, and they are just going to simply infiltrate. This water gets infiltrated with the natural aquifers, and in that entire area the water gets contaminated. So, this is due to the acid mine drainage and the mine tailings, the mine effluents getting mixed, getting leached and mixing with the aquifer. Land use change and urbanization I have already talked about, from forests to grasslands, going to barren lands, then concrete lands, different kinds of urban structures. We are just removing more of the natural cover and making our own modified designed covers. So, that is there. Climate change huge. What is climate change? Climate change shifts the patterns of rainfall. Okay, prolonged prolonged areas, prolonged time of aridity. Okay, so more and more frequency of droughts, more and more frequency of extreme events, but shorter duration of the rainfall season. So, how the rainfall season has changed, you can yourself see that there are more sudden extreme events rather than more distributed monsoon system. So, previously what we used to see is that the rainfall is very well distributed in the monsoon months, but now there is more intense extreme events, and the rainfall during the other time is very low. So, such rainfall pattern shifts, changes the hydrological pathways, changes mixing of the river water, groundwater, everything gets changed, and the groundwater is seriously impacted by such shifts in the rainfall patterns and the drought and everything. Poor well construction and maintenance I have already mentioned. Lack of monitoring and governments. Yes, there are bodies, there are a lot of government bodies that is supposed to be taking care of the natural water resources, but sometimes the requirement of the subject may be in much more depth, and the people who are managing, they sometimes have difficulties in getting more suitable people for governments and maintenance of those of the resource. So, our government is working towards it, but yes, we are on a path towards more for better water, sustainable sustainable water goals, and the government has taken, I think, immense measures now. Slowly I think changes will be observed. I will be focusing on this particular topic of natural groundwater contamination, something which is called as geologic contaminants, and the more common ones are arsenic, and you can see here they are related, the arsenic, fluoride, selenium, uranium, they are related to more cratons, more orogenic events, belts. So, what happens is that these are the rock types, more felsic rock types, were cratonic granitite, old peninsular granitic, gneissic basins. These kind of rock types, they have minerals in which arsenic, selenium, uranium, they are present in huge concentration, even though as impurities. Okay, so they can be there in huge concentrations as impurities in the structure of these minerals. and naturally when it is getting weathered, it gets deposited from these orogenic belts, because here in these orogenic belts means mountainous regions, it gets deposited due to higher physical weathering. There is more sediment formation, more depositional settings are there, so it just gets deposited in the foreland areas and all. So, these foreland basins, they naturally have a high concentration of these metals, and when the water is there, the water can have a lot of natural processes, natural weathering related processes by which the metal gets dissolved into the water. For us humans, we need to be cognizant of what kind of reactions is happening, and this particular area uranium is supposed to be high, this particular area arsenic is supposed to be very high. We need to know, okay, which areas what is high, and by doing which kind of processes it will get more mobilized. For instance, if I make the aquifer more oxic, then my uranium is going to get more oxidized and it is going to become more mobile, and the more oxic form of uranium is the more toxic form. So, in an confined aquifer, if I am digging up a well and I am making that environment oxic, then my uranium which is in the reducing condition, which is which is harmless, which is which was supposed to be precipitating out, that may become oxic, it may become now more toxic and more available to the environment. So, by doing different kinds of activities, we have mobilized different metals. So, arsenic, uranium, they are not only natural, but we also have helped them get mobilized into the system. Fluoride, selenium, they are more dependent on the rock type. So, fluoride is coming from more fluoride bearing minerals. So, there is CF2 and calcium fluorides, basically some kinds of topazes, so apatite, these are the kinds of minerals which are there in the, if they are there in the geology, then it will come into the groundwater because of its high reactive in nature. Some other metals such as uranium and cadmium, they can have different kinds of sources. So, for instance, geogenic, it can have both geogenic sources, anthropogenic sources, and uranium can even have cosmogenic sources. So, there can be mining activities. So, mining of coal, phosphate mining, oil and gas industry, uranium metal for as a metal that can come. So, uranium waste from nuclear power plants and during wars, that waste can add in. Then agricultural practices, if you are using a lot of fertilizers, okay, that can add into the uranium. Then oxidative dissolution of reduced U4 minerals by nitrate. So, if you have nitrates, if you have iron, they are going to oxidize the reduced uranium and bring it as more oxic uranium, and this oxic uranium is the more toxic uranium. And of course, if there is a declining water table, then more and more air enters the water table. So, this air is atmospheric air which is more oxygen rich. So, the water table gets oxygenated. Okay. Similarly, for cadmium in groundwater, there can be many types of sources. There can be a natural and anthropogenic. So, natural, what will be there? The volcanoes, it is naturally there in the biota. So, the forest fires, sea spray, soil particles, they are all there. Rock weathering from sulfide rocks, carbonates, phosphates, organic matter, all of them, whatever in minute contribution cadmium they are having, they can add in. But what is the more important is anthropogenic. So, mining, landfills and metal industry. So, wherever cadmium is used to make alloys, okay, for particular purposes, that is there. Then fossil fuel combustion, they are going to have it from organics, but the burning process is anthropogenic. So, we are burning the fossil fuels. Phosphate fertilizers, nitrogen fertilizers, all this are going to be rich in cadmium. Okay. Then there is traffic. So, basically again fossil fuels, groundwater extraction, again oxygenation, all of this is going to add to the cadmium concentration in groundwater. These are some excellent review papers, you can refer it back. Uranium and cadmium, selenium, fluoride, nitrate, arsenic, these are some extremely well known contaminants in groundwater, and they are very well studied. And this is another review paper by Mukherjee et al. In 2024, which shows the complex pathways and the entire ecosystem as a whole. And you can see that how from the mountainous areas where the rocks are getting generated, you can have different kinds of weathering and sediment kind of deposition, and the interactions that it has with different kinds of reactions. Okay. I urge you to go back and read this paper and develop a more better understanding of particular systems that you are interested. Just know that when we look into one particular system, it's not alone. So, when we are looking into groundwater, it's not separate from the entire ecosystem, it's there, but it's also interacting with the atmosphere, with the river, with the weathering activities, with the anthropogenic activities. So, all of that is happening. So, when we look into the system together, something like this, that we get to understand the implications, the huge implications of the processes. So, the different zones that gets created, the mobility of different metals in the different zones, and why certain activities release certain metals, and what kind of mediation strategies we should be using. So, if you are interested, you go back and look into the papers and develop better understanding of these systems. So, with that I will end this particular lecture, and we are going to look into ocean water in our next and begin our next module. So, with that, thank you and see you in the next lecture.